According to the National Electrical Code, specifically Section 310.15b2, when not more than 3 current-carrying conductors of a feeder or branch circuit are contained within a raceway, the ampacity of each conductor is determined as if those conductors are the only conductors contained in the raceway. This section addresses situations where multiple conductors are grouped together in a conduit or raceway, potentially leading to heat buildup and requiring ampacity adjustments. The primary concern when running multiple current-carrying conductors in a single conduit is heat. Electrical current flowing through a conductor generates heat due to the conductor's resistance. When multiple conductors are bundled together, the heat generated by each conductor can raise the overall temperature within the conduit. This increased temperature can degrade the insulation of the conductors, potentially leading to short circuits, ground faults, or even fires. To mitigate this risk, the NEC provides guidelines for adjusting the ampacity of conductors based on the number of current-carrying conductors in a raceway. The term current-carrying conductor refers to conductors that carry electrical current under normal operating conditions. This typically includes the ungrounded hot conductors and, in some cases, the neutral conductor. Grounding conductors are generally not considered current-carrying conductors for ampacity adjustment purposes. The NEC provides tables that specify the allowable ampacities for various conductor sizes and insulation types. These ampacity values are based on the assumption that the conductors are installed in free air or in a raceway with only a few conductors. When the number of current-carrying conductors exceeds 3, the NEC requires that the ampacity of each conductor be derated or reduced to account for the increased heat buildup. The amount of derating depends on the number of conductors and the ambient temperature. To determine the appropriate ampacity adjustment, you must first determine the number of current-carrying conductors in the raceway. This includes all ungrounded conductors and any neutral conductors that carry significant current. In a 3-wire circuit serving a nonlinear load, for example, the neutral conductor may carry a substantial amount of current due to harmonic currents. In such cases, the neutral conductor must be counted as a current-carrying conductor for ampacity adjustment purposes. Once you have determined the number of current-carrying conductors, you can consult NEC Table 310.15 colon to determine the appropriate ampacity adjustment factor. This table provides adjustment factors for various numbers of conductors, ranging from 4 to more than 20. The adjustment factor is a percentage that is multiplied by the allowable ampacity of the conductor to determine the derated ampacity. For example, if you have 6 current-carrying conductors in a raceway, the adjustment factor may be 80%. This means that the ampacity of each conductor must be reduced to 80% of its original value. In addition to the number of conductors, the ambient temperature also affects the ampacity of conductors. The NEC provides correction factors for ambient temperatures above 30 degrees Celsius or 86 degrees Fahrenheit. These correction factors are applied in addition to the ampacity adjustment factors for the number of conductors. To determine the appropriate temperature correction factor, you must first determine the ambient temperature in the area where the conductors are installed. This can be done using a thermometer or other temperature measuring device. Once you have determined the ambient temperature, you can consult NEC Table 310.15 colon to determine the appropriate temperature correction factor. The correction factor is a percentage that is multiplied by the allowable ampacity of the conductor to determine the derated ampacity. After applying both the ampacity adjustment factor and the temperature correction factor, you must ensure that the derated ampacity of the conductor is sufficient to carry the load. The load is the amount of current that the conductor is expected to carry under normal operating conditions. If the derated ampacity is less than the load, you must either increase the size of the conductor or reduce the load. It is important to note that the NEC provides exceptions to the ampacity adjustment requirements in certain situations. For example, if the conductors are installed in a raceway that is no more than 24 inches long, the ampacity adjustment requirements may not apply. Additionally, if the conductors are used for certain types of equipment such as motor control circuits, the ampacity adjustment requirement may be different. When dealing with existing installations, assessing compliance with current NEC requirements can be more complex. The key is to ensure the existing wiring method is safe and suitable for the applied load, considering the number of conductors, conductor size, breaker size, and the actual load being served. The existing installation might have been compliant with the code in effect at the time of installation, but changes in the NEC over time might necessitate a review. In the scenario described, there are more than 3 current carrying conductors in an existing conduit. The conductors are number 12 American wire gauge, or AUG, and the branch breaker is rated at 20 amps. The load is estimated to be less than 9 amps for all receptacles. Now, let's analyze the situation based on the NEC. Number 12 AWG copper conductors, with typical insulation types like THHN or THWN, have an ampacity of 30 amps, as specified in NEC Table 310.16, before any dirting factors are applied. However, NEC Section 240.4d addresses the overcurrent protection for conductors. For number 12 AWG copper wire, the overcurrent protection device I.A. The breaker generally should not exceed 20 amps unless specific exceptions apply. This is to protect the conductor from overheating due to excessive current. In this case, the breaker is already at 20 amps, which aligns with the code requirements for the overcurrent protection of number 12 AWG conductors. Since there are more than 3 current carrying conductors in the conduit, NEC 310.15b3 requires ampacity adjustment factors to be applied. The adjustment factors are based on the number of current carrying conductors in the raceway. Here is a breakdown of how to apply the adjustment factors. Firstly, determine the number of current carrying conductors. This is crucial because the adjustment factor depends on this number. Secondly, find the appropriate ampacity adjustment factor from NEC Table 310.15 colon. For example, if there are 4 to 6 current carrying conductors, the adjustment factor is 80%. Thirdly, calculate the adjusted ampacity. Multiply the initial ampacity of the number 12 AWG conductor, which is 30 amps, by the adjustment factor. If the adjustment factor is 80%, the adjusted ampacity would be 30 amps times 0.80, which equals 24 amps. Finally, verify that the adjusted ampacity is greater than the breaker size than the actual load. In this case, the adjusted ampacity is 24 amps, which is greater than the 20 amps breaker and the estimated load of less than 9 amps. Therefore, the installation is compliant with the NEC. It's also essential to consider the terminal temperature ratings of the equipment. NEC 110.14c requires that conductors be selected and installed so that the equipment termination temperature ratings are not exceeded. Typically, breakers and receptacles are rated for 60 degrees Celsius or 75 degrees Celsius. The ampacity used must be appropriate for the lowest temperature rating of any connected termination. In summary, the installation appears to be compliant with the NEC provided that the adjusted ampacity of the conductors is sufficient for the load and the breaker size, and that the terminal temperature ratings are considered. The key considerations are the number of current carrying conductors, the ampacity adjustment factors, the breaker size, the actual load, and the terminal temperature ratings. It is important to note that this analysis is based on the information provided in the current edition of the NEC. Local codes and regulations may vary, and it is always recommended to consult with a qualified electrical inspector or engineer to ensure compliance with all applicable codes and standards. Also, consider future expansion. If there is a possibility of adding more load or more conductors in the future, it might be prudent to use larger conductors or separate conduits to avoid potential problems. Regular inspections and maintenance are essential to ensure the continued safe and reliable operation of the electrical system. Check for signs of overheating, such as discolored insulation or loose connections, and address any issues promptly. Ensure that all electrical work is performed by qualified and licensed electricians who are familiar with the NEC and local codes. Proper documentation of the electrical system, including circuit diagrams and load calculations, can be helpful for future maintenance and troubleshooting. When modifying existing electrical systems, it is important to consider the impact on other parts of the system. For example, adding more load to a circuit may require upgrading the service entrance or other components. Before making any changes to an electrical system, it is always a good idea to consult with a qualified electrical engineer to ensure that the changes are safe and compliant with all applicable codes and standards. If the load increases significantly in the future, a more detailed load calculation should be performed to ensure that the existing wiring and equipment are adequate. Additionally, consider the voltage drop in the circuit. Excessive voltage drop can cause equipment to malfunction and can also be a safety hazard. The NEC provides guidelines for voltage drop in branch circuits and feeders. When performing electrical work, always follow safe work practices. Wear appropriate personal protective equipment such as safety glasses and gloves, and use insulated tools. De-energize circuits before working on them, and verify that they are de-energized using a voltage tester. If you are not qualified to perform electrical work, hire a licensed electrician. Electrical work can be dangerous, and it is important to take all necessary precautions to protect yourself and others. Remember, electrical codes are in place for safety. Adhering to these codes minimizes risks of fire, electrical shock, and equipment failure. Regular training and updates on electrical codes are important for anyone involved in electrical work. This ensures that they are aware of the latest requirements and best practices.